Question 3. This one is AB and BC. A pie is taken from a hot oven and put on a table. The internal temperatures of the pie at time t minutes can be modeled by the function h that satisfies the differential equation right here, where h of t is measured in degrees Celsius and h of 0 equals 75. This one is the initial condition. For t greater than 0, it's known that h of t between 20 to 75. Question A. Explain why the following could not be the slope field of the differential equation dh over dt equals negative 1 over 15 times h minus 20. Okay, so observe that the slope field given right here always positive, right? Look, use the Christmas tree trick. The lights going this way, positive, lights going this way, negative, right? Now, we look at this one right here, we see that h of t is always greater than 20, right? So then h minus 20 always greater than 0, right? And then a positive number multiplied by a negative number right here, always less than 0. It tells us that every slope in the slope field should be negative. This one contradicts the given one right here, which is the given slope field shows positive slope, so it cannot represent these differential equations, right? Now question B. Find the slope of the line tangent to the graph of h at time t equals 0. Right. So we need to use the differential equation and the initial condition h of 0 equals 75, right? So it's going to be negative 1 over 15 times, substitute 75 for h minus 20, right? So it could be negative 1 over 15 times 55, right? Simplify this one, it's going to be negative 11 over 3. Or you can leave the answer like this, that's fine, right? Therefore, the slope of the tangent line at t equals 0 is negative 11 over 3 degrees Celsius per minute. Now question C. It can be shown that the second derivative of the function h is 1 over 225 times h minus 20. The line tangent to the graph of h at time t equals 0 is used to approximate h of phi, right? The internal temperatures of the pie at time t equals 5. It is approximation an overestimate or underestimate for the actual value of h of phi. Alright, now since h of t is greater than 20, right? So it tells us that h of t minus 20 greater than 0, right? So from these two guys right here, we can conclude that the second derivative of h always positive, right? This guy is positive, this guy is positive, so when you multiply it's going to be positive, right? It tells us that the function h is concave up. So if the function h is concave up, it could be something like this. Then the tangent line should be below the curve, right? Therefore, the tangent line approximation at t equals 0 given an underestimate, right? Now question D. Use separation of variables to find an expression for h of t, the particular solution to the given differential equation with initial condition h of 0 equals 75, right? So we need to divide both sides by h minus 20 and multiply both sides by dt, right? So it's going to be, now we're going to integrate both sides. The left hand side is ln of h minus 20. The right hand side is negative 1 over 15 t plus c, right? Use initial condition right here to solve for c, right? So we have ln absolute value of 75 minus 20 equals negative 1 over 15 times 0 plus c, right? So c equals ln of 55, right? So we're going to substitute this guy back over here. So we have, since the initial condition is positive, so we can eliminate the absolute value side right here, right? Now we just exponentiate both sides, so it's going to be h minus 20 equals e raised to the negative 1 over 15t plus ln 55, right? And this guy actually e raised to the negative 1 over 15t times e raised to the ln 55, right? And then this guy actually 55, right? So we can bring 55 to the front, right? So we have h minus 20 equals 55 times e raised to the negative 1 over 15t, right? Add 20 both sides, so h equals 20 plus 55 e raised to the negative t over 15. This one is the final answer. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand